Today we're going to solve quadratic equations by graphing. Again, remember a quadratic function is either y equals ax squared plus bx plus c, or in function form, it's f of x equals ax squared plus bx plus c. Y and f of x are somewhat interchangeable. F of x just represents a function. So when we graph, we're going to replace that f of x with a y. We're going to solve a quadratic function by setting y equal to 0 to get the x-intercepts. Our quadratic equation, remember, is where a does not equal 0. Otherwise, that would not be a quadratic equation that we're dealing with. The roots are the x-intercepts of the quadratic equation, and zeros are the roots or solutions where the x-intercept of the function is what we're finding. They are the x values when f of x equals 0. So when a function equals 0, we call them zeros. It's just a technical term when we're dealing with functions. Equation has roots. So again, an equation, the technical term for roots, is similar to a function with its technical term of zeros. To solve a quadratic equation graphically, first we're going to find the axis of symmetry, where x equals negative b over 2a. Remember, that's the x-coordinate of your vertex. We're going to make a t-table using x values around the axis of symmetry. We're going to graph the points, find the x-intercepts, or the solutions of the quadratic equation. If the graph crosses the x-axis in one point, we have one solution, meaning the vertex would be directly on the x-axis. If our graph crosses at 2 points, we have two solutions. And if the graph crosses in no points, we have no real solutions. We would have imaginary solutions, possibly only. Exact roots may not be found when a graph crosses the x-axis between two integers, which may happen. Moving to our first example, we're going to solve the quadratic equation x squared minus 3x minus 4 equals 0 by graphing. Remember, in order to do that, we have to make a t-table. It doesn't hurt to write down your a, b, and c values. This tells me that my quadratic equation should open upward because my a value is positive. I then can solve for my axis of symmetry, negative b over 2 times a, so 3 over 2 times negative 4. When we simplify this, 2 times 1. A value is 1, not c value. When we simplify this, we get 3 halves as the x-coordinate of our vertex. So when we make our t-table, 3 halves, or 1.5, goes in the middle of our t-table. For graphing purposes, I would recommend doing 2 to 3 values above and below the x-coordinate of your vertex. This will ensure that your graph will hopefully cross the x-axis. If not, with these values, you may have to add more values greater than and less than that vertex x-coordinate. All right, so when we simplify this, meaning we're substituting all of these x values back into our function to solve for the corresponding y coordinates. So take the time, remember, when you're doing this, to plug all of your x values back into your function to solve for y. Once we've done that, we can plot our points on our graph. So we start with 4, 0, and then we should have a symmetrical point on the other side, so we have 0, or negative 1, 0, 3, negative 4, and 0, negative 4, 2, negative 6, 1, -6. And then our vertex is at 1.5, -6.25. So that's right about here. All right. When we do this, we're going to trace out our parabola. And we can see we try and make a U shape for our parabola. Now, we're looking to see where our graph crosses the x-axis. Our graph crosses the x-axis at these 2 points. These are exact values and they are solutions. So our solutions, in this case, we have 2 solutions at -1, 0, and at 4, 0. We're going to solve the next one by graphing as well. So remember, we want our equation to be equal to 0. So set your equation equal to 0. You can see your A, B, and C values. We're going to find the x-coordinate of our vertex. And then make our t-table. So our vertex is at 2. Three values less than, 3 values greater than, and we substitute those back in. Once we've done that, we can start to graph. So our vertex is at 2, 0. And so on from there. And the last 2 points are off of our graph, but they are up here. Now, when we look at our graph, we intersect the x-axis at only 1 point. So our point of intersection is right here. So our solution is the point 2, 0. One solution for this graph. Moving on to the third example, we're going to solve this quadratic equation by graphing. Remember, if exact roots cannot be found, state the consecutive integers between which the roots are located. So I do not want you to estimate where your roots would be located. We want to state the integers between which the roots are going to be located. We'll get to that in a minute, but let's pull out our A, B, and C value since our equation is already in the correct format. Okay, find the x-coordinate of our vertex. And then make our t-table. Vertex is at 3. Okay. Plug all of our x values back in. When we graph, our vertex is at 3, -6, which is here. Two and 4, -5, 5, -2, 1, -2, and then we have 0, 3, and 6, 3. Okay, there's our graph. Now you can see when we look at our graph, it crosses the x-axis twice, but not at nice points. It crosses in between 2 points. So because we don't know exactly what those values of intersection are on our x-axis, we're going to state the integers between which those two values occur. When we look at our location, it's going to be between the x values of 0 and positive 1, and then the x values of 5 and 6. If we look at our t-table, that's another way to tell where your roots are going to be located. We look at the y values in our t-table, and when they interchange from positive to negative or negative to positive, that is where we're going to have our roots. So right here, we can see by looking at the y values in our t-table, we go from positive 3 to negative 2. So there should be a root located between those 2 points. And we go from negative 2 to positive 3. So again, we should have a root located between those 2 points on our graph. So here, notice in the table that the value of the function changes from positive to negative and negative to positive. So the solutions occur between x equals 0 and 1 and x equals 5 and 6. Those would be your two solutions. Again, please do not estimate what those values are. State between which two integers the solutions or the roots would lie.